Today I remembered a marker, a whiteboard marker, because I was going to demonstrate the treemap construction algorithm. But I noticed that there's no whiteboard here. So I forgot to bring a whiteboard. Next time I'm going to bring a whiteboard too. I guess I'm going to try again on Monday. But if there's an emergency, I can make a demo, like a video demo or something like that. You can actually see it from like the two 2016-2017 lectures. It's in there. I was in a class with a whiteboard and a marker, and I drew it out. It's not that easy to see, I think. Okay. If there are no questions, or if there are questions, just interrupt at any time. I think we almost finished the hierarchies last time. It wasn't quite finished. Did anybody try the disk inventory X software? Anybody try that? We tried that. The first time I saw that, I was like, I have to download that and try that like that. It looks so cool. Okay, a little refresher from last time. We were looking at hierarchical data representation, normal, these are so-called normal trees, just trees. We looked at a traditional file system. That is a hierarchical representation of files. We looked at an interactive word tree hierarchy, Venn diagrams, tree maps. This is an example from the tool formerly known as Many Eyes that disappeared, unfortunately. And this is very similar to the example that you see in assignment 1. That's the disk inventory example. And we talked about the benefits of tree maps. And there are just a few more examples. Like this is a map of the so-called markets. This is from marketwatch.com. Anybody here into financial investments or like studying finance, things like that? World of finance. There used to be a website called smartmoney.com, and I think like marketwatch.com bought them. I think something like that. Anyways, that's a tree map of the stock trading activity. Anybody here ever bought stock before, or traded stock, sold stock? Only one person? Carlo, I would think that that would be something you would be interested in. I think that my psychic powers are sending me signals of that's in your future. That is something you're going to be interested in. Anybody know the traditional way of representing and looking at stock market trading volume? A line chart is one way. Any other ways? You've all seen it before, that's why I'm asking you. The traditional, has anybody ever watched like the business news or the financial news? Like CNN Finance or something like that. The traditional way of like conveying stock market trading volume is with this ribbon that slides across the screen very fast, and it shows the trading symbols. So every company has 3-letter trading symbol, APP or APL for Apple, and it slides across the bottom of the screen very quickly with an up arrow or a down arrow with a number. Anybody ever noticed that before? That's stock trading. That's like a traditional way. And if you like see, there are movies like New York Stock Exchange movies, and people are looking up at these numbers scrolling by. Like, it's insane. Anyway, Anyway, it's totally, I can never read those things, like, going like, I can never read those things. Anyways, this is a proper way to represent and visualize that same information. It's a tree map. The green represents buying activity, so that causes the price of the stock to go up. And the red represents selling activity, which causes the stock price to go down. And then the size of the rectangles indicates the volume, how many stocks have been traded. And the thing is, you can see the whole market activity in just like 2 seconds. You can see what's happening. You get a complete view of the markets. And you can hover your mouse over the individual squares and get the exact stock trading data. It's a great example. Great example. Here's an example of tree maps used in conjunction with 3-dimensional view. So this is flow visualization data. And the flow visualization data is being clustered. Their vectors are being clustered together. Vectors that are all aligned in the same direction. Now, the challenge here is, imagine you have, in 3 dimensions, a set of volumetric clusters. How do you pick and choose clusters in the middle of the volume or in the rear? Like, you'd like to be able to take your mouse pointer and just click on a cluster and get more details. But you cannot always do that in 3D. So you can represent the same clusters in a tree map in 2-dimensional hierarchy rather than a 3D hierarchy. And there's no problem pointing the mouse and clicking. That's nice. Pointing the mouse and clicking in 2 dimensions. No problem there. Please work. I hope it works. Taking a second to boot up. Oh, nice. Okay. It's not lit up here. It's okay. This is a snapshot from an interaction where a person is clicking on different rectangles and then moving up and down the hierarchy. That's one of the features of tree maps. You can click on any rectangle and then expand it to fill the whole space. Also the inverse. I just threw this in here for fun. This is an example of cartographic tree maps which combine cartograms and tree maps together. There's a video about that in assignment 1, actually. In assignment 1, there's a tutorial on the data set that talks about cartographic tree maps. Somebody that was very clever asked me about this, a question about this. Is that gentleman here? He had a huge beard. He asked me a question about this, and I was surprised. He's not here. I don't see anybody with a huge beard. You have a big beard, wasn't you? Like really big, powerful, like huge beard. He sticks out. He said, "Oh, where's the hierarchy in your cartographic tree maps?" And I was like, wow, I can't believe you just asked that. I didn't say that. I was just surprised. Because it's a good question, and it's a good observation. So in this example, every rectangle represents a CCG. The same CCGs that from assignment 1. Your assignment 1. This is a visualization from the same data as assignment 1. And then in each CCG, we have rectangles that represent the different disorders, like coronary heart disease in the top left. Right, heart failure is the next one. Stroke is the next one, and so on. And the number of cases is mapped to the size of the rectangle. So bigger the rectangle, the more people are diagnosed with that problem. So here, the big one, right, is called hypertension or high blood pressure. So that's a very prevalent problem. And you can see that, like, look, it's a huge problem, very prevalent. It's the highest prevalence in all of England from these particular disorders. This one is diabetes. But he said, where's the hierarchy? I don't see really, he didn't say I don't see a proper hierarchy, but he wanted to know more information. I mean, there are two answers. One is it's a very shallow hierarchy. It only has two levels, like the CCG nodes, and then one subdivision into the different diagnoses. So it's a very shallow hierarchy. But if you do watch the video, you can see we show an example where we cluster the CCGs together into another level of the hierarchy and show that it follows that the tree map hierarchy principle. It's very short though, it's like 5 seconds long, the demonstration video. So I told him to go check that out, even though he's not here. But since he's not here, we can talk about him and make fun of him. Anyway, it's a good question. Okay, and that's about it for the hierarchical stuff. Now, you might be, I know what some of you are thinking. Are those all the hierarchical database methods? Somebody's thinking that. I'm getting a signal. The answer is definitely not. I just went over a few brief examples. There are lots more. And you'll see them when you start to explore the software, the different software tools. You can Google like hierarchical database and click on images and get lots of different images. I've never done that actually. Let's just for fun do it. Hierarchical, if you can spell that. Okay, yep, there are radial versions of tree maps. There's a tree map. This one's not very good. There are certainly other methods. Not just that one looks nice. So you're right. Good observation. There are a few tree map websites too. Is there a survey on the? Are you talking about the survey paper?
No, it was on the site. It's on treeviz.net.
Treeviz.net. That might be a, yes, okay, a visual bibliography. Well done, well done. This should be, yes, you get bonus points, definitely. Definitely, this is very good. I'm surprised this isn't a survey paper. Or maybe it is and I don't know about it. How to cite this site. Let's see what it says. Okay, tree is it? Is it not a? Okay. It is an article. It's just an article I didn't know about. It's a short article of only 4 pages. Definitely you get extra points for that. Any other questions? I might have to do some mind reading exercises. It's a good thing I can read your minds because otherwise there wouldn't be very